Today we are going to be talking about solving one and two-step inequalities. By the end of this video, you should be able to solve one and two-step inequalities both algebraically and graphically. So first, let's take a look at a situation. We have that Brett has a $30 online gift card. He plans to buy as many books as he can. The cost of each book is $4, and there is a single shipping charge of $2. How many books can he afford without spending more than his gift card amount? With this problem, the numbers are small enough that you might be able to figure it out without writing an inequality, but for some other problems that we'll see later, you're going to want to write an inequality, otherwise it's going to take a very long time to figure it out by hand. So first, let's talk about an inequality. An inequality is an open sentence that contains one of these four symbols. So let's define these symbols. The first one is less than. When we graph this on the number line, we are going to use an open circle and then an arrow to the left. When you write out a number line, for example, something like this, the smaller numbers are always on the left. So if I am saying that something is less than -1, I would put an open circle at -1 and then an arrow going to the left. The next symbol we have is greater than. The graph for that will be an open circle at the number and an arrow going to the right. So for example, if I said that something is greater than -3, I would put an open circle at -3 and an arrow to the right along my number line. Next, we have less than or equal to. This line under the less than symbol means equal to. When we graph this, we're going to use a filled in circle or a closed circle and an arrow to the left. So if I say that something is less than or equal to -1, I put a closed circle at -1 to show that it could equal -1, or it could be any of these numbers that are less than -1. Finally, we have greater than or equal to. Again, the line under the symbol means that we are including our value. It means it could be equal to a number or greater than. So we're going to put a closed circle and then an arrow to the right. So for example, something could be greater than or equal to -3, which means it could be -3, or it could be any of these numbers to the right. Here, we are told to select the values of x that satisfy this inequality. Satisfy means make it true. So if I want to know x is less than 8, which of these numbers are less than 8? Well, 2 is less than 8, 10 is not less than 8, -3 is less than 8, 8 is not less than 8. Those are equal, so that will not be included. If we are going to graph this on a number line, we would just say that it is less than, which is an open circle, and to the left of 8. If we look at the second problem, x is greater than or equal to -5. So it could be equal to or it could be greater than. Well, 0 is greater than -5. -4 is greater than -5. -10 is not greater than -5. If we graph this on a number line, we have -5, 0, 5. Since it's greater than or equal to, we have a closed circle. And since it's greater than, we're going to the right. Now let's look at some algebra problems. Here we want to solve and graph these inequalities. All of the rules are the same as when we solved equations, but we have one extra rule. When you multiply or divide both sides by a negative, you have to change the direction of the inequality. And I'll show you what that means when we get to that problem. So first, we have x minus 8 is greater than 10. Start by drawing your line, just like you did when we solved equations. To get x by itself, we just do plus 8 on both sides. And we get that x is greater than 18. And that's it. To graph this on the number line, greater than means an open circle and to the right. Next, we have -15 is greater than or equal to 3x minus 6. So I'm going to draw my line. I'm going to start by adding 6 to both sides. Then I divide by 3. We do not switch the direction of the inequality because the number we divided by was not negative. Now, I don't like the way this looks, so I'm going to switch this around. When you switch the x and the -3, you also have to switch the sign. So I'm just making this easier to read. So I have that x is less than or equal to -3. So less than or equal to means I'm going to have a closed circle, and less than means I'm going to the left. For this next problem, I could distribute if I wanted to, or I could divide both sides by -5. Since the number I divided by, this number, was a negative, I'm going to switch this from being a less than to a greater than. Then I'm going to subtract 2 from both sides. And you might need a calculator to help you with this subtraction, but you get 12 over 5. So x is greater than 12 over 5. As a decimal, this would be 2.4. So when I graph this on the number line, I'm going to write a few more numbers this time. .4 is about here. Since it's greater than, I'm going to use an open circle going to the right. Next, let's take a look at some word problems. Now, there are a lot of vocab words in this unit because there are a lot of words in the English language that represent greater than or less than, or greater than or equal to, or less than or equal to. These are just a few of the words that you could see. First, you have the word at least. An example might be, you must earn at least $50. If we are writing an algebraic expression, this would be x is greater than or equal to 50, because at least means that much or more. Next, we have no more than. I could say you spend no more than $20. In algebra, that would be x is less than or equal to 20. No more than means you could spend less. You could spend exactly $20, but it cannot be more than $20. So it's less than or equal to. Next, at most. You could say you run at most half a mile. In algebra, this would again be less than or equal to. Next, you have more than. So you could say you eat more than 4 cookies. More than is just another way of saying greater than, so we would have x is greater than 4. Less than is pretty obvious. We're going to have less than in our equation. We could say you walk less than 2 miles. That would be x is less than 2. Finally, we have no less than. So I could say you must be no less than 54 inches to ride the roller coaster. That means you could be exactly 54 inches or you could be more than 54 inches, but we have x is greater than or equal to 54. So let's look at a couple of word problems. First, we are told that we want to write the inequalities represented by the statement. The number of hours a full-time employee can work a week without getting overtime pay is at most 40 hours. Well, we said on the previous slide that at most means less than or equal to. So the number of hours that you work is going to be less than or equal to 40. The next problem says, in order to ride the triple threat roller coaster, a rider must be at least 42 inches tall. In the chart above, at least means greater than or equal to. So you must be greater than or equal to 42 inches. Let's take a look at the last example. Kevin has $515 in a savings account at the beginning of the summer. He wants to have at least, let me underline at least, $200 in the account by the end of the summer. He withdraws $25 each week for food, clothes, and movie tickets. How many weeks can Kevin withdraw money from his account? So first of all, withdrawing money means you are taking it out, so we are subtracting. He starts with $550 and he takes away $25 every week. He wants to have at least, we said at least means greater than or equal to $200 at the end of the summer. So now we just solve like a regular equation. We subtract $515, you get negative 315. Then you divide by negative 25. Since we are dividing by a negative, we need to change the direction of the sign. And if you divide this in your calculator, you are going to get a decimal. You get 12.6. Well, if he takes out money one time a week, he can't have this 0.6. Since our inequality is a less than, we're going to round down and say that the number of weeks has to be less than or equal to 12. So how many weeks can he withdraw money from his account? No more than 12 weeks. Let's go back to situation number 1 at the beginning of the notes and take a look at that. Brett has $30 on an online gift card. He plans to buy as many books as he can. The cost of each book is $4. There's a single shipping charge of $2. How many books can he buy without spending more than his gift card amount? Well, he has $30. Each book is $4. We learned in our equations unit that each usually tells us where the x is. It's $2 for shipping. This says without spending more than. So not more than or no more than, which means we're going to use the symbol less than or equal to. Then we can solve. Subtract 2 from both sides. Divide by 4, and we get the x is less than or equal to 7. So that means that Brett cannot buy more than 7 books. He could buy less than 7, or he could buy exactly 7.